Hello. So I would like to continue our discussion. So I will discuss to you the use of muscles. So we have examined the different muscle fiber types, and we understand that all fibers in a motor unit, when stimulated, it can act at the same time, and that different fiber types are recruited in stages depending on the force required to perform the activity. So I would like to move back to the whole muscle level, now that the process and its functions of the muscle, to turning our attention to how the muscles work to produce the movement. So in the uses of muscles, we actually have the types of muscle contraction. So types of muscle contraction, muscle movement generally can be categorized into three types of contractions. So we have concentric, static, and eccentric. And I know you already discussed it, as you remember, in your senior high school, no, sa physical education ninyo, you already discussed this one. But let's just recall what are the three types of contraction. So just like in many activities, such as running, and the three types of contraction may occur in the execution of a smooth and coordinated movement. So for the sake of clarity, for you to understand though, so we will examine the three types of contraction separately, right? So a muscle principal action, or when we say shortening, is referred to as concentric contraction. This is the most familiar type of contraction. So remember, when we say shortening, the type of contraction is concentric, right? So to understand the muscle shortening, okay? Kasi nga the concentric contraction is shortening, right? So let's go back, or let's recall to our past discussion of how the thin and thick filament slide across each other. So I should remember the thick and thin filament, now in the sliding filament theory, it slides across each other, right? So muscle can also act, right, without moving. So when the muscles act without moving, when this happens, the muscle generate force, but its length remains static or unchanged, right? So this is called the static or isometric muscle contraction. Okay? So in a concentric contraction, the thin filament are pulled toward the center of the sarcomere because joint movement is produced. Concentric contraction is considered as dynamic uh, contraction. So just like what I've said, that when the muscles act without moving, so syempre ginatawag natin na siya as static or isometric muscle contraction. So because of the joint angle does not change, a static contraction occurs. For example, when someone tries to lift an object that is heavier than force generated by the muscle, or when one supports the weight of an object by holding it um, steadily, no, with the elbow, with our elbow flex. So in both cases, the person feels a muscle tense. Man. So makafeel ang muscle tense. But there is no joint movement. No, mafeel he or she can feel the muscle tense, but the joint while lifting the object, or the muscle is not moving. So in a static contraction, let's recall to the process of the sliding filament theory. The myosin cross bridges form and recycle to produce force. But the external force is too great for the thin filament to be moved. So that is the reason why that they remain in their normal position. So the shortening can't occur, right? So if enough motor units can be recruited to produce sufficient force to overcome the resistance, a static contraction can become dynamic one. Okay, mo na siyang tandaan niyo. Okay, tungod the muscles. Okay, remember that muscles can exert force even while lengthening. So this movement is an eccentric contraction. So the eccentric contraction, because joint movement occurs, this is also dynamic contraction. The best example of an eccentric contraction is the action of our biceps when we extend the elbow to a lower heavy weight. Just like for example, when we lift a dumbbell, okay? So when we lower the dumbbell down, no? That's the action of the eccentric, okay? And in that case, our thin filament are pulled farther away from the center of our sarcomere. Essentially, parang mag-stretch ta. So just like for example, when we lift our, when we lift a dumbbell, so automatic ka na, shorten siya, di ba? Okay, shorten. So, pagbaba natin sa dumbbell, so automatic, mga siyang ginatawag natin eccentric traction. It's because the thin filament are pulled farther away from the center of our sarcomere. Alright? So, that's the difference of the three contraction, no? It's just like, always remember that the concentric is shortening, right? And the eccentric is lengthening. Alright? So, pag static gan siya or isometric, they also have muscle contraction, but the length of our muscle is still remains or unchanged. Right? Okay, next is generation of force. Okay, this is the uh, best discussion. So whenever muscle contract, whether the contraction is concentric, static, or eccentric, the force developed must be graded to meet the needs of the task or activity. Okay? So, just like for example, when we generate the force in our muscle, I would like to give an example in golf. Okay, so golf. The force in golf, the force needed to hit the golf ball, gusto ka mapalayo ang bola, no? Pila ka yard or pila ka meters ang mabot sa bola from the tee, no? So the amount of muscle force that you need to develop is dependent on the number and type of motor units that activated. So we have the frequency of stimulation of each motor unit. So we consider the size of our muscle, no, the muscle fiber type, the sarcomere length, and the muscle speed of contraction. So if we want to hit the golf ball away from the tee, pila ka meters ang malagpot sa golf ball. So, kailangan nato ang amount of muscle force na how much motor units being activated when we hit the golf. So, we will also consider, that's like I've said, the the frequency, of course, the size of muscles in our arm, okay, the muscle fiber types, in our arm, and then the length of our sarcomere, and also the speed no, the speed matters when we hit the ball if we want to generate great force. Just like for example, if you hit the golf ball slowly, so you cannot drive away the ball, no? Pila ka meters. So kailangan mo siya speed ning pag-hit nimo para at least ma-generate ang force. It's because that's the frequency stimulation of your motor units, no? Ang speed sa imong pag-hit sa ball. Alright? So that's how you generate the force. And and another example, when we generate the force in our muscle, just like for example, kasi nga merong pagkakaiba when we consider the speed of muscle of generation of the force. So like for example, sa atong golf nag-example nako, so kailangan siya speed, right? So sa pag-lift na tong object or when we lift a dumbbell, the generation of force is different. Why it is different? It's because when lifting a heavy dumbbell, we should consider also the weight of the dumbbell, and of course the size of your muscle and the muscle fiber that activated when you lift the object. So in order for you to lift no the dumbbell, so the speed of contraction when lifting the dumbbell is kailangan slowly. Okay? So, ano, kailangan to slowly ang pag-lift sa dumbbell. For that, it's because the frequency, so kailangan to mabalan ang muscle tense na to kung sa kabugat ang dumbbell na ginawait na to in order for our motor units to be activated. Right? So, kailangan slowly siya para maka-generate ka og tamang force based dito sa weight na ginalift nimo. Right? So, di na siya pwede na, just like for example, like if you lift a 100 kilogram or 50 kilogram or 60 kilogram na dili siya sakto sa size of muscle nimo, so automatic, when you lift it quickly, no, dili gini mo na siya ma-lift. Right? So, isipon nimo the size of your muscle and then gi-lift nimo ang 60 kilograms quickly, automatic, dili maka-generate of force ang imong muscle. So, dili sakto ang motor units na ma-activate niya. Okay, so that is why the frequency of stimulation of our motor unit, the motor unit is activated, of course, the size of our muscle, the muscle fiber types, our sarcomere, and the speed of contraction is kailangan to i-consider for us to be able to generate the force needed of the task and activity. Alright? So next is the motor units and the muscle size. So more force can be generated, right, when more motor units are activated. So kailangan nyo siya remember. No, just like we said kanina that more force can be generated when more motor units are activated. So type 2 motor units generate more force than type 1 motor units because type 1 motor units contains more muscle fibers than type 1 motor unit. Okay? So, mao na siyang always na i-remember ninyo when we talk about the motor units. So, meaning to say that if we want to generate more forces, so kailangan more motor units ang i-activate nato. Okay, para matagaan niya o more force atong muscle. And type 2 motor units generate more force. Mao na siya remember ninyo than type 1 motor units. It's because the type 2 motor units contains more muscle fibers than type 1 motor units. So, speed of contraction, just like what I've shared to you in the generation of force. Okay? So speed of contraction, the ability to develop force also depends on the speed of muscle contraction. So during concentric or shortening contractions, maximal force development decreases progressively at the higher speeds. So just like what I've given you the example earlier, no, when you try to lift a heavy object, syempre you tend to do it slowly. Okay? So kailangan slowly gina siya when we want to lift heavy object. So that's how we maximizing the force na kailangan i-apply nato dito sa pag-lift nato. No, kaya ang ingon ganina, if you grab it quickly and you grab it quickly and try to lift it, so syempre ma-fail jud ka, no? Dili gini mo na siya ma-lift ang dumbbell. And the worst case scenario with that is na there are possibility na you will injure yourself. No, kay tungod kasi wag ta kabalo mabali mong kamot or yung joint nimo, no? It's because the pas imong pag-lift sa dumbbell. And however, with eccentric or lengthening contraction, the opposite is true, no? Fast eccentric contraction allow maximal application of force. So, mao siya kung example ganina tong golf, right? Tong golf and ang pag-lift nato og kanang dumbbell. Alright, so muna siya na you should always consider no uh, the speed of contraction when we develop force or generate a force. So that's I think that's the end of the continuation of our of this topic. So you understand how the our muscles uh or movement is produced because of how we generate the force. Okay, and I will continue to explain to you the next lesson that you need to understand. So that's all. Thank you, and God bless everyone.